In this video, we are going to learn a very important concept, that is quantum numbers. Quantum numbers. What are these numbers? We already know the main levels are divided into the sublevels. Sublevels are bifurcated into the orbitals. Orbitals can accommodate electrons. The description about the distribution of electrons in various main levels, sublevels, orbitals is called electronic configuration. You already know that. So, to describe about the main levels, sublevels and orbitals, including electrons, some certain numbers are provided for us. Means, around the nucleus, where the electrons are revolving in a particular orbit, can be considered as quantum numbers. Now the quantum numbers describe about the space, where that space around the nucleus, where the electrons are found and their energies also. Means where the electrons are found and what their energy can be described by using quantum numbers. This is only the significance of quantum number. We can write this is the significance of quantum numbers. These numbers are describing about the space around the nucleus where the electrons are found and their energies. Now, there are totally 4 quantum numbers are there. Those 4 quantum numbers are principal quantum number, represented by letter N, the angular momentum quantum number, represented by letter L, the magnetic quantum number, represented as ML, the spin quantum number, represented as MS. These are all the 4 quantum numbers indicates and studies about the various main levels, sublevels, orbitals and electrons. Let us discuss clearly one by one the principal quantum number, angular momentum quantum number, magnetic quantum number and the spin quantum number in an order. Let us discuss the principal quantum number. Principal, in the name only there, it is the first quantum number, and then it was discovered by Niels Bohr. It is represented by letter M. See, N means values will be there. There should be some positive values only. These positive values are 1, 2, 3, 4, 5. And it is related to size and energy of the main shells. Why? Because the electrons are accommodated in the orbitals, orbitals are in the subshells, subshells are in the main shells. If you can understand, this is the nucleus and the electrons are revolving around the nucleus like this, where N is equal to 1 is equal to K, N is equal to 2L, N is equal to 3M, N is equal to 4M. Like this we can represent. Actually they are there in the form of full circles we should draw, but as per the convenient I draw only half circles. Right. Shell N1, then it is called K shell or otherwise K orbit. N is equal to 2 L shell, N is equal to 3 M shell, N is equal to 4 N shell, N is equal to 5 O shell. Like this, how many shells are there? Infinity shells are there, but till now we are using only 5 shells. What it says, as the size increases, energy also increases. Why? Because the electron is there in the first level has 1 quanta of energy, second level 2 quantas of energy, third level 3 quantas of energy, fourth level 4 quantas of energy. As the size is increasing, energy of the orbit also increases. These are the basic features of principal quantum number. Now, Let us discuss the second quantum number, that is angular momentum quantum number. Angular momentum quantum number are also called as azimuthal quantum number, or also called as subsidiary quantum number. Azimuthal quantum number or subsidiary quantum number. It was discovered by Sommerfeld. Principal quantum number discovered by Niels Bohr. Angular momentum quantum number discovered by Sommerfeld. It is represented by letter M. It is represented by letter L. Now, it is related to the shape of a particular subshell. Main levels, principal quantum number. Sublevels or subshells represented by angular momentum quantum number. These values means L values depends on the principal quantum number. How? For example, say if we consider n is equal to 1, that is equals to k level, it has only one sublevel, that n is equals to 0 is called as sublevel. Where n is equals to 2, that is equals to L, it has two sublevels, they are L is equals to 0s, L is equals to 1 is called P. Means if you observe here, n is 2, L value starts from 1 and ends at 1. This means this 1 can be written as 2 minus 1. For example, if we consider n is equal to 3, that is equal to m, it has three sublevels, they are S, P, D. Their L values are L is equals to 0, L is equals to 1 and L is equals to 2. This 2 can be written as 3 minus 1. Means angular momentum quantum number L depends on the principal quantum number n. And these values are always starts from 0 and they are ending at n minus 1. If you consider n is equal to 4, that is capital N level. Now, how many sublevels are there in that? If the principal quantum number is 4, the number of sublevels is also 4. But their values starts from 0, ends at 3. L is equals to 0, S sublevel. L is equals to 1, P sublevel. L is equals to 2, D sublevel. L is equals to 3, F sublevel. We should remember one thing. If this sublevel S starts from main level 1, sublevel P starts from main level 2, it is represented as 2P. Main level sublevel D starts from main level 3, represented as 3D. If the sublevel S is in main level 1, it is called 1S. So in the second main level S is there, it is called 2S and 2P. In main level 3 S, so it is called 3S. Main level 3 sublevel P, so it is called 3P. Main level 3 sublevel D, it is called 3D. That is the method of representation. Once again you check the representation. For example, if n is equals to 4, how many sublevels are there? 4 sublevels, they are S, P, D, F. They are represented as 4S, 4P, 4D, 4F. If n is equal to 5 is there, it has 5 sublevels. The fifth sublevel is G. It is represented as now 5S, 5P, 5D, 5F and 5G. It represents. Before that numerical value indicate the principal quantum number. Next represent indicates the angular momentum quantum number. If L is equals to 0, sublevel S, L is equals to 1, sublevel P, L is equals to 2, sublevel D, L is equals to 3, sublevel F. Let us discuss the third quantum number, magnetic quantum number. Let us discuss the third quantum number, that is magnetic quantum number. This magnetic quantum number was discovered by Landay and is represented by letter ml. Principal quantum number discuss about the size of main levels. Angular momentum quantum number discuss about the energy of sublevels, whereas magnetic quantum number discuss about the orientation of orbitals in the space. So it is discussing about mainly orbitals in the space, right? Now it gives the number of orbitals present in a particular sublevel, mainly number of orbitals that present in a sublevel. Let us see here. L is equals to 0, it is called S sublevel. You already know this. L is equals to 0, S sublevel. It has only one orbital. That orbital value, numerical value is 0. L is equals to 1, that is P, has 3 orbitals. Those values are -1, 0, +1. Means we can represent the P like this. Here -1, 0, +1. How many total number of orbitals are? 3. See, how to remember this? If L is equals to 1, here it is started at -1 and ended at +1, including 0. Now comes to L is equals to 2, that is equal to D sublevel. Now what are those ml values? Ml is nothing but magnetic quantum number values are, as in the case of above, it should start with -2, -1, 0, +1, +2. It is started at -2 and completed at +2, including 0. Now let us come to L is equals to 3. As per the rule, it should start from -3, end at +3, including 0. If you count the total numerical numbers, they become 7. For example purpose, if L is equals to 10, how many values are there? Those values start from -10, ends at +10, including 0. Then how to calculate this rule? These values are represented by 2L plus 1. 2L plus 1 is the formula to calculate the number of orbitals that present in a sublevel. See the examples. One example we may solve. For example, say L is equals to 3. How many number of orbitals are there? Apply the formula 2L plus 1, that is 2 of 3 plus 1, that is 6 plus 1, that is 7. See here, L is equals to 3, that example we considered, and by applying the formula of 2L plus 1, now we can get 7 orbitals. So 2L plus 1 is the formula for to count the number of orbitals that present in a given sublevel L. Formula for the number of orbitals present in a sublevel is given by 2L plus 1. These orbitals, which has 5 orbitals, 7 orbitals, they have equal amount of energy. Means orbitals belongs to the same sublevel. Orbitals of the same sublevel has equal amount of energy. Such orbitals are called degenerate orbitals. Orbitals which belongs to the same sublevel, which has equal amount of energy, are called degenerate orbitals. As per this definition of degenerate orbitals, S has only one orbit, degenerate orbitals. P has 3 degenerate orbitals. and those values are -1, 0, +1. L is equal to 2, D has 5 sublevels. They are -2, -1, 0, +1 and as well as +2. They have equal amount of energy. L is equal to 3, that is equals to F. ML starts from -3 ends at +3, so total values are 7. These 7 has equal amount of energy. So there are 7 degenerate orbitals are there in L is equals to 3. There are 5 degenerate orbitals are there in the sublevel D. There are 3 degenerate orbitals are there in the sublevel P. There are only 1 degenerate orbital is there in the sublevel S. Let us discuss the last and fourth quantum number, spin quantum number. Now, let us come to the spin quantum number. It was discovered by Uhlenbeck and Goudsmit. It is represented by letter MS. Right. What it indicates? It indicates the intrinsic property of electron. Intrinsic property means special peculiar property of the electron. Electrons are negative charged particles, we already know. Whenever an electron is rotating either in a clockwise direction or in an anti-clockwise direction. Why? Because electrons are revolving around the nucleus. When an electron is revolving around the nucleus, it must have some orientation. Orientation means direction. Either it is in the clockwise direction or in the anti-clockwise direction. Of course, the electrons are present in the orbitals. Means, now the question is, how many electrons are accommodated in an orbital? The number of electrons that are accommodated in an orbital is only 2. The number of electrons that are accommodated in an orbital is only 2. See, for example purpose, L is equals to 0, that is S, has only one orbital. So according to this, only 2 electrons are there in S sublevel. Sublevel S contains only 2 electrons. L is equals to 1, that is equals to P, as per the formula 2L plus 1, and it has 3 orbitals. According to this, 3 into 2, 6 electrons are accommodated in the sublevel B. That will be maximum number of electrons. Then what are the minimum electrons? Maybe 0. Now L is equals to 2, that is equals to D. By applying the formula 2L plus 1, 2 2s are 4 plus 1. So totally it contains 5 orbitals. These 5 indicate the number of orbitals. So 5 into 2, that is equal to 10 electrons. This means maximum electrons that are accommodated in the D sublevel with 5 orbitals are 10. L is equals to 3, that is equal to F, that is 7. By because 2L plus 1, 2 3s are 6 plus 1, 7 orbitals. According to the formula, 7 into 2, 14 electrons are accommodated. Sublevel S, 2 electrons because 1 orbital. Sublevel P, 6 electrons because 3 orbitals. Sublevel D, 10 electrons because it has 5 orbitals. Sublevel F can accommodate maximum of 14 electrons because of 7 orbitals. Let us discuss now. This means every orbital can accommodate only 2 electrons. Only 2 electrons. These 2 electrons orientation, one will be there in the clockwise direction like this, clockwise, or otherwise in the anti-clockwise direction. If one electron is in the clockwise, another electron is in the anti-clockwise direction. See, the clockwise direction of an electron is represented by an upward arrow or also called plus half. The anti-clockwise direction is represented by downward arrow or otherwise minus half. These are all various type of quantum numbers that we discussed till now, which indicates energy of main levels, capacity of sublevels means orientation of the sublevels. Next, orbitals and electrons. So to discuss about every main feature, there are 4 quantum numbers are considered. Like this, we can learn the concept of the quantum numbers. Thank you.